we say there's a correlation between two events, is really saying that there's a connection. So one might think that there is a correlation between a drop in temperature and the number of sales of jerseys in the second-hand clothing shop. And one might usually be inclined to suggest that there is a positive correlation in that situation. In other words, the colder it gets, the more jerseys are sold. In the same way, one could say there would probably be a negative correlation between an increase in temperature and the sales of jerseys. So as the temperature went up, the sales of jerseys went down. And that would imply a negative correlation. So in this video, we're looking at how we can possibly measure the strength of an association between two variables. So how strong is the correlation? In this section, we're looking at what we call the Pearson's correlation coefficient, or R, and it will always lie between -1 and 1. You can see in the table that it will tell you if R is 0, there's no relationship between X and Y. So the data is just randomly scattered, and you can see on the next slide, you'll see what we mean on the scatter plot. If R is equal to -1, there is a negative correlation, and it's a perfect linear correlation. All data points will lie on a straight line, your regression line. As X increases, Y decreases, and you can see that in the second picture over the page. In a similar way, if R is equal to 1, you have a perfect positive correlation. If R is negative, so between 0 and -1, there's a negative linear correlation. However, the closer to -1, the stronger the negative correlation. And in the simile at point number 5, the closer R is to +1, we say it's a stronger positive relationships. You can see in the picture, so in the first one, we've got R is 0, and your dots are just scattered randomly all over the page. In the second one, you've got R is -1, and all your points are lying on a straight line. So we say that is a perfect negative correlation. In figure 3, R is equal to 1, showing that there is a perfect positive correlation. And in figure 4, we've got R is equal to 0,32. Now the fact that R is positive describes that there's a positive correlation. In other words, as your variables on the x-axis increase, so do the ones on the y-value. So you can see your points are actually increasing. As x increases, y increases. However, the 0,32, that's closer to 0 than it is to 1. So we would say there's a weak correlation. You can see that the points are not tightly packed around that line. So a weak correlation might suggest that a nonlinear relationship might fit better. So think about what we discussed on the previous video and in grade 11, where possibly an exponential or a parabolic graph might have a better fit. Correlation does not necessarily imply a cause and effect. It's just an observation. An example I remember looking at in a grade 9 lesson was, when there are more fish in the sea, are there more seals? What was the cause? What was the effect? In other words, did the increase of fish bring the seals? We're not sure about. The R value will be more accurate for a bigger sample. That goes with most of our data. Well, the most important question is, how are we going to find R? Well, if you think back to the previous video, we found the regression line, y hat equals a plus bx. You follow exactly the same steps until you get to your screen that looks like that. And what we're looking for this time is the R. We're looking for that regression coefficient. Correlation coefficient. And if you use the headmaster data, which you'll find in your 911 booklet, you'll see that you get 0,909. Now that's obviously a very strong correlation. You will often be asked in an exam to describe the correlation once you've found that correlation coefficient. So you're going to find R in your calculator. And the closer it is to 1, so here we've got R is 0.9, we would say that is a strong positive correlation. In another example, you got R is equal to negative 0.8, and that would be a fairly strong negative correlation. Here's question 1, which is an example of an exam question. What I suggest you do is grab your calculator, work through the question. You might need to refer to your 911 notes. It might be easier than looking back at the video. Work through the question, press pause at this point, and when you're ready to check your answers, you can turn the page. So press pause, do some calculations. Right, hopefully you've done your calculations and you've restarted the video. These should be your answers. Okay. Notice in this case, in question C, they asked you to find the R value, 0.1. That is a strong positive correlation. So check your answers. You might want to pause again while you're quickly checking. Question 2, I would say if you're a bit unsure when you did question 1, you might want to do question 2. And again, the answers are on the next page. So press pause while you do the questions and then restart the video to check. Okay, final page, your answers to question 2. Don't worry if you didn't do the whole of question 2. Obviously, it's good practice, but tomorrow in class, you'll be doing some exam questions for finding the regression line and for finding the correlation coefficient. All right, and we're almost up with the paper 3 stuff.